Okay, number 15. Concentrate on one book. After that, do your past paper. Physical quantity X is related to the mass M and distance S and time T, acceleration due to gravity G by the equation X equals to mg st square over 4m. Deduce the dimension of X. I can use unit if you're not don't like dimension, and then convert it to dimension. Okay, go to each of the dimension. Right, write the equation down. Dimension of mass is m. Dimension of s is l. Dimension of acceleration is lt minus 2. Dimension of time is t squared. Right, 4 pi doesn't have dimension. Then simplify it. Right, this one becomes 0. So t to the power 0 is 1. So it's ml squared. Okay, I think the answer in the book is wrong. If you work with unit also can. It's a matter of change it, that's all. You still get the same answer. Okay. That's the next question.
The next question, 18.
This morning is a bit slow. Don't know why the computer is so slow today. Air resistance F on a car traveling with velocity V in air of density rho is given by the formula where K is a dimensionless constant. Dimensional constant means it's just a value, a number only. So don't have to worry about it. You can throw it away. And A is the effective cross-sectional area of the car. Determine the value of X, Y, and Z. Okay. Find your dimension for force. Right? Dimension for force is ml e squared. And then K doesn't have any dimension. V is the speed. Right? Speed to the power of X. And your rho.
The force is kg ms 92. That's why it became mlt 92, right? So
Force is mass of acceleration. So mass, this is your
kg
mass.
ms 92.
LT minus 2. You want to use unit, you can use unit. No problem with that.
Kg turn into m. M turn to L, S turn to T, 92, right? So
Yeah.
okay.
That's your speed to the power of X, and then your density, mlt minus 3 to the power of Y, and then your area is m squared to the power of Z. Then simplify it. There's a Lx, then L minus 3Y, L to the power 2Z, and then T to the power minus X. No T here, so there's M to the power Y. That's all. Then equate. The best way is to equate your M first. M y equals to 1. Equating indices of y of m to the power 1 here. So y equals to 1. Then after that, go and equate your t. Right? Minus x. Minus x, your t. T in this case is minus 2. Okay, so x is 2. Then equate your final one. Your L. Oops, something wrong here. Okay, your x minus 3y plus 2z. And then look at here, your L is to the power 1. And then put in your value, 2z minus x minus x minus 2 minus 3y take over, it becomes plus 3y, right? Y equals to 1, so it's 3. And simplify. That's your answer. Okay.
So teacher, but the MLT -2,
Which one are you having problem?
no. Okay, the MLT -2, then you equate it, right? Then why you separate LT -1x and then ML -3y? The one I don't get it.
Which part are you talking about? This one.
Yes, and the one before that.
The one before that, you must go to each of the steps. Here is velocity. This is speed or velocity. Then after that, you go to density. This is
Oh.
density. And this area. That's for area. Then you simplify it.
Z. Then the K, teacher.
K, I told you a dimensionless constant. Dimension constant, you don't
Oh
need
yeah,
to worry
no
about it.
need
It's
to
just a
care.
number.
Oh, understood, sir, understand. 19, teacher.
The speed v of waves in the sea is related to the wavelength lambda and g, the acceleration due to gravity, by the equation that k is a dimensionless constant, so you can throw k away. Show that the equation is dimensionally homogeneous. That means they have the same unit or the same dimension. So you go to your dimension for left-hand side. Left-hand side is the speed, lt minus 1. Dimension of right-hand side, which is k root g over L. So as I said, k, don't need to worry. G is acceleration, right? Lt minus 2. Lambda is wavelength, so it's L. Then square root is to the power of half. Then simplify, this is L square. L square times half is L. And t minus 2 times half is minus 1. Right? So you have shown that the dimension of left-hand side equals dimension of right-hand side, or the unit of left-hand side equals unit of right-hand side. Up to you to use whichever you prefer.
Hey, what's the unit? G unit is L, right, sir, technically.
No, G is acceleration due to gravity. Lt minus 2.
So MS -2. Oh, yeah. Okay. So then the lambda is L lah.
Yeah.
Okay. We'll answer. So yeah, both sides is equal lah. That means.
Yes, both sides must have the dimension or the unit of speed.
So both of them, that's why they say they want to find dimensionally homogeneous, means that means they want it to be the same.
Yep.
Okay, got it.
The speed of the wave is 100 meter. Right? This is just to get you to use a formula, calculate the frequency. So this one is your this semester's work or your SPM work. You have to use the formula V over lambda, 9 over 100. So it's 0.090 hertz. Value of K. Right? Now you have got the wavelength is given you. Your speed is given you, G, you know, then can calculate your value of K. Right? K is just your V divided by root G over M. V is 9, that's your 9. G is, you are told to use 10. Right? Use 10, they tell you use 10, use 10. Then lambda is, oh, I make a mistake here. It should be 100 meter, not 1000. Sorry about that.
Yeah, 100.
Yeah, what am I doing? So is the answer correct? Is the answer correct?
So basically 10 times 100 square root.
Correct. My carelessness. Correct. Answer is correct. Okay with that so far? Answer is correct. I am just careless. Okay, we need to know how to play with the formula. It is required of you. The speed of another wave is 12.24 meter per second. Find the wavelength and frequency. Right? This is just playing with formula, that's all. Okay. You can use this formula back if you want to and calculate if you want to, or you can take all the variable to one side. Right? G is a constant. Only variable is V over lambda. It will up to you to prefer. Right? I square that. I put it upside down. That's how I get this formula. Right? This is the new one. This is the old one. Then I put in your value. Lambda 2. Right? Lambda 1. Then V2 square. Right? The whole thing. V2 or V1. The whole thing square. First one is 100. And V2 is 12.4. Right? V1 is here 9. And the whole thing square. Using a calculator. 190 meter. And after that, you can use to know the speed, know the wavelength. Just use your V over lambda. Calculate out. Okay, anything not clear?
Yeah, I'm good, teacher. Because basically the square root lambda is just square it, right? Sir?
Yeah, square the speed. I don't want to work with square root. I square it.
Yeah, but then how you know it's equals to constant and then you can do straight away like that? Sir?
G is a constant. I can take the G out. K is a constant. So my variable is V over root lambda from this equation.
Also just take out whatever constant value and then put the one which is not constant equals to
If you
constant.
don't want, you can calculate, no problem. You know your constant already. You can use back the equation. This
You
equation.
can still substitute also lah.
Just substitute in, that's all. Your choice. So then to follow me, if you don't like the way I do it, you can just use the original equation. Right? Your lambda is given you, your speed is given you, then you can calculate your lambda. Right? You should get the same answer. And then after that, use this equation to calculate your frequency. You have no choice this semester, you have to work hard with it. Number?
20.
Explain why the unit of work is derived unit. Right? Unit is a combination of base unit by multiplication and division, or both. Right? That's why we call it a derived unit, or both. So you have multiplication, you have division. I think you put it here easier, both multiplication and division. Rather than add extra in. That's all. The density and pressure P of the gas is related to the expression. Anything can come out as long as they tell you what is the thing. You have never seen the formula, it can still come out. It's just getting you to do the fundamental, understand the English, that's all. Where C and gamma are constant. Okay. Given that the constant gamma has no unit, deduce the unit of C. Okay, C is usually the speed, but doesn't matter. They don't require to know that. Work it out. Gamma is just a value, a number. So you can work with unit if you want to. Gamma, no unit. Pressure. Pressure is just your, right? You either memorize it or you use, derive it. Have I done something wrong here? Why is my pressure? Oh, I have derived already. Pressure you straight away. There's a unit for pressure. There's a unit for density. If not, go to use force over area. Derive it. Okay. And then half is the square root. So kilogram cancel off. This one take to the top is plus 3 minus 1 square root that. I still got meter. Right? Plus 3 minus 1 is 2. M to the power 2. Square root that is m to the power 1. Then square root of this one is minus 1. So unit of speed. C is the speed of the gas molecule. From your answer, suggest what is the, we have done that. Okay, anything that is not clear?
Answer. So C, then you square root it, and then you get 1 over to power 1 over 2. Then easy to simplify lah.
Yeah.
Actually, if you want to do the other way, also still can lah.
When you use dimension also can, no problem. It's a matter of getting the answer. As long as your working is
I mean,
correct.
if you never square root, also you have got C square equals to m square s negative 2 technically, right, sir?
You don't square root it, you get wrong answer.
Yeah, yeah, correct. No, you will get m square s negative 2, but and if you square root it, you get ms negative 1 technically, right?
Yeah.
Oh, because they want the unit of C. That's why.
Yeah, they don't C square. They want unit of C.
Teacher, but you can pay to that one. What's that? Change it, right? So to derive unit. Cannot. No need.
What are you talking about?
MS negative 1 become LT negative 1.
Yeah, you can use dimension. LT minus 1 also can. As I say, it's your choice.
They never told anything specific.
Even they ask you to they ask you to find unit only. So how you do it is your choice. Then you give them the unit, MLS minus 1, to use dimension. Then tell them the unit.
Okay.
You are very slow lah. Still revising one topic. This semester you are going to be in trouble, as I said to you, because you have not been putting enough work there. So I have to tell your mother already, you better do something. You know you are wasting your money here. You cannot afford this semester already to slack. So far you have not putting in the effort. That's why you are not doing well. Tuition won't help you unless you go back and do your homework and apply yourself. I'm the one learning. You're not the one learning at all. Okay, next question. Discuss briefly whether in general the method of dimensional checking can possibly confirm an equation is correct. Okay, dimensional checking can possibly confirm that the equation is correct, as the dimension on left hand side equals dimension on right hand side. Okay, Of course, you have to qualify it lah. Yeah, what is wrong with the... Okay, you just have to qualify with your addition, then you have a problem, no? Or taking to the power, as long as it's multiplication and division, you can use dimension, because the dimension, you are basically adding each term, having the same dimension, that's all. Okay, so the flow of liquid of density rho around an obstacle of width B changes from streamline to turbulence when the critical speed is reached. If eta is the viscosity of the liquid, which of the following equation below relates V to rho, P, and eta? Right? So this one no choice. You are told A, B, C are dimensionless constant, so you have to work through each of them. No? Right? First, right? That's why you are saying dimension of left hand side is equals dimension of right hand side. That's what you are doing. The dimension of speed is just that. Right? A, dimension of area. A, right? What have I done? Oh, A is, oh, A, you are told constant, so you don't need to worry. And then you call eta. Eta is what am I doing? If eta is the viscosity of liquid, which of the following equation, okay, you have to change in 10 minutes time, relates V to rho to P and eta. Where did I get eta? Did they give the value for eta? I got B is del. How do I get this one? Eta. And then there's your density. I think if they haven't given you eta, you cannot solve it. Right? This one I probably get it from a textbook, because there's nothing for you to learn from here. It's not something that you are supposed to know. Okay.
What's that, sir?
I say the value for eta, they didn't give you. They didn't tell you what it is. They tell you viscosity only. So they cannot expect you to know the unit or the dimension. Okay, so it's not a fair question, this one. So I thought
cancel the question.
I can cancel a question, but if they are given you, you can treat it as given. No? Eta is given. That's a unit for eta. Right?
Which one?
Coefficient of
unit for eta?
viscosity, this one. That one, that's called eta. Coefficient of viscosity, this one. Work it out. So A cannot be. B, the same thing. Right? That's a coefficient of viscosity. B is length, density. Then cancel your this L minus 2. Take to the top there. You still got plus 2 minus 1. You still got 1. T minus 1. M and M cancel. So it looks like B is the answer. Okay. Ken, anything not clear?
Means the viscosity thing is ml -1, T -1, right?
ml minus 1, T minus 1. That one you have to, they have not given you. So you have to get it from textbook. So I don't think this is a fair question.
All right, I cancel the question.
No, you still need to know. You still need to know.
Yeah, yeah.
Except they didn't, if they come out in exam, they have to give you the coefficient of viscosity. Okay, we take 5 minutes break.
All right, okay.
Or any question you want to ask? If it's a short,
Take the break first, Lacha.
take a break. Okay.